function f0 comma pi maps to r be defined by f theta equal to, the function is f theta equal to sine theta plus cos theta whole square. So if you open it up, it will be sine square theta plus 2 sine theta cos theta plus cos square theta plus, let us write this sine theta minus cos theta power 4 as square power square. Sine theta minus cos theta square, if you open up, it will be sine square theta plus cos square theta minus 2 sine theta cos theta whole square. So this will be equal to sine square plus cos square is 1. 1 plus sine theta cos theta is sine 2 theta. 1 plus sine 2 theta plus, this is 1 minus sine 2 theta whole square. So if you open up the square, it will become sine square 2 theta minus 2 sine 2 theta plus sine 2 theta. So minus sine 2 theta plus 1 plus 1 2. So this is the function f theta on simplification. Now suppose the function f has local minimum at theta. What is the domain of theta? 0 to pi. So theta belongs to 0 to pi. And we need to find out the point of local minimum for the function. So let us go for the derivative. F dash theta will be equal to, derivative of sine square 2 theta will be 2 sine 2 theta into cos 2 theta into 2 minus 2 cos 2 theta. So taking 4 cos 2 theta common, we will have sine 2 theta minus 1 by 2. So where the derivative will be equal to 0? Cos 2 theta is equal to 0. Cos 2 theta is equal to 0. That means 2 theta equal to pi by 2. Within the domain theta is 0 to pi, that is 2 theta belongs to 0 to 2 pi. 2 theta belongs to 0 to 2 pi. So 2 theta can be pi by 2 or 3 pi by 2. So theta equal to pi by 4 or 3 pi by 4. Two values. And the other factor will be equal to 0, that is sine 2 theta equal to half. That is 2 theta equal to pi by 6 or 2 theta is equal to 5 pi by 6. That implies theta equal to pi by 12 or theta equal to 5 pi by 12. So we got 4 values of theta, pi by 4, 3 pi by 4, pi by 12, 5 pi by 12. These are the 4 points where the derivative will be equal to 0 and the derivative is supposed to change the sign also. So let us draw the wavy curve of this particular function. So if I draw the wavy curve, so these are the points where the sign is going to change. That is pi by 12, next is pi by 4, next is 5 pi by 12 and finally 3 pi by 4. These are the values of theta between 0 to pi where the sign is going to change, right? So we need to check the sign of the derivative at the interval created by this values. So if you start the wavy curve from here, 0 to pi by 12, if you start from here, initially in the neighborhood of 0, in the right neighborhood of 0, theta is more than 0, sine 2 theta is a very small positive value. So this difference is negative and cos 2 theta is positive. So product will become negative. Sine 2 theta will be very close to 0. So this will become negative, this is positive. So it will start from a negative region. It will be negative, then it will change to negative, then it will change to positive, then again negative, positive, finally negative. So minus to plus, to minus, to plus, to minus. So what are the points of local minima? For local minima, we know that the derivative changes sign from, for local minima, derivative changes sign from negative to positive. So where the negative to positive change is happening? At pi by 12 and 5 pi by 12. So these are the 2 points of local minima. So local minima at theta equal to pi by 12 and 5 pi by 12. These are the 2 values of local minima where the derivative changes from negative sign to positive sign. So theta belongs to this particular set lambda 1 pi up to lambda 1 r. That means lambda 1 pi is equal to pi by 12 and lambda 2 pi will be equal to 5 pi by 12. So lambda 1 equal to 1 by 12 and lambda 2 is equal to 5 by 12. There are two values. So we need to find out the sum of the two values, that is lambda 1 plus lambda 2 will be 6 by 12. So the answer will be 0.5.